Naming hydrocarbons. Alkanes, alkenes, and alkynes. The IUPAC names of hydrocarbons has two parts. The first part of each name, called the prefix, indicates the number of carbons in the longest carbon chain. We'll call that the main chain or the backbone. The second part of each name, the suffix, indicates whether the hydrocarbon is an alkane, ending in ane, meaning single bonds, an alkene, ending in ene, meaning double bonds, and an alkyne, ending in ine, meaning triple bonds. This table gives you the prefix terms for many carbons in the main chain for a variety of formulas. So meth is 1, eth is 2, prop is 3, but is 4, etc. Have this available as you work through this lesson. So here's an example, drawing a structure for an alkane. Propane is a fuel commonly used in gas barbecues. Draw a structural formula for propane and write its formula. Write the carbon main chain called the backbone. By referring to the table on the previous slide, you will find that 3 means prop, or prop means 3. This gives the first half the name, the prefix, as prop. So draw the carbon main chain showing 3 carbons. Attach your bond symbol. Next, add single chains to each carbon, total of 4 lines. These lines represent where hydrogen atoms will bond to the carbon atom. So we put 3 on the first carbon because we already had 1. We put 2 on the second and 3 on the third. So we have every carbon being satisfied with the rules of bonding. All 8 atoms are needed to fill all bonds. So now we'll draw the H around the molecule. So the formula for propane is C3H8. Draw a structural formula and write the formula, the molecular formula, for each of the following alkanes. Butane, commonly used in lighters, contains a 4-carbon chain for but joined by single bonds. Take a minute to draw this. When finished, go to the next slide to see if you are correct. So we have 4 carbons because of but. They're all single because of the ane. We add the bonding lines, we add the H, and we'll see we have C4H10, butane. Now, draw a structural formula and write the formula, the molecular formula, for each of the following alkanes. B, octane, found in gasoline, contains an 8-carbon chain. 8 and oc mean the same thing, joined by single bonds. Take a minute to draw this. When finished, go to the next slide to see if you are correct. I'll wait. So, did you draw 8 carbons? Add the bonding lines, add the hydrogens, and you had 18 hydrogens. So the formula, molecular formula, is C8H18. Now, let's try methane. Methane is a natural gas that is used in homes and school science labs. It's a single carbon, that's the term meth, and let's draw it. So we have 1 carbon, add the bonding lines, and we have 4 hydrogens, methane. Now, let's move on to alkenes and alkynes. The general rule for naming alkenes, meaning double bond, and alkynes, meaning triple bonds, are similar to naming alkanes. Use ene at the end if it's an alkene, and use yne at the end if it's an alkyne. You must also give the position of the double or triple bond by giving the number in sequence of the carbon atom it is attached to. This is an important step that we must follow. Okay, 2-pentene. This would mean a double bond is found at the second carbon. Let's sketch it out. Draw structural formula and write the molecular formula for 1-hexene. Write the carbon backbone of the appropriate length. Hex means 6. Determine the position of the double bond. The ene tells there's a double bond linking 2 of the carbon atoms. The number at the beginning of the name tells which carbons the double bond is attached to. Note, the IUPAC system means the molecule is numbered from the end, left or right, that gives the lowest number for the double or triple bond. Since the alkene is 1-hexene, the double bond starts at the first carbon atom and ends at the second carbon atom. So 1, and then we'll show the double bond. Fill in the remaining bonds with hydrogen atoms. Be careful with the double bond because it already uses 2 more, so you have to decrease the number of hydrogen bonds. So this will end up 1-hexene with C6H12. Since there are 6 atoms of carbon, 12 atoms of hydrogen, the molecular formula is C6H12. All right, here are some examples for you to try, and I provided the solutions. Here are some more examples. Now, in this example, it uses an alkyne, which just means a triple bond. Can you name this hydrocarbon? Please note, as you move on in your organic chemistry, you will add a third part to naming hydrocarbons not covered in this course.